My goal for this session would be first to give you sort of a reminder of how LeanSig looks like and what the current API is that we sort of expose to the clients, and then we can discuss about how to change it to make it more flexible and to make it more useful for the clients. As a sort of quick reminder in the beginning, how does LeanSig work? It follows this XMSS approach where you have a tree of one-time public keys. So the leaves in this Merkle tree are one-time public keys, and these one-time public keys are just a bunch of, in the concrete case of Poseidon, field elements or a bunch of hashes. So we have a bunch of hash chains, and the ends of these hash chains are our one-time public key. And then we have the starting points of these hash chains, which are our one-time secret key. And all together here could be treated as the secret key. But of course you can, this is a lot of data. So think of this tree as being very, very large, 2 to the 32 leaves. Then of course you don't want to store all of these one-time secret keys. You just expand them from a PRF seed using any sort of PRF. And I guess the question that I've already mentioned on Saturday is that there's sort of a trade-off between signing and memory, like signing time and memory. You can either store the entire Merkle tree, so you would not store the leaves. That's even more data, but like you can store just the PRF seed. But then you can either store the entire Merkle tree. That would give you extremely fast signing, and that is what's currently implemented. But of course, the secret key is now large, and we will see how large in a second. The other option, or the other extreme, is to regenerate the tree when you are signing. This is extremely slow, but it would give you small keys. And now the question is, how do we balance between these two things? How do we make this flexible for the clients? So what I want to talk about is sort of this interface between the signature library and any Lean consensus client. So ideally, we want to encapsulate as much cryptography as possible in this signature library and not make the clients deal with the cryptography internals, but we still need it to be flexible. Okay, so let's look at the current API, what sort of the signature library gives us. Again, there's this sort of tree with, say, 2 to the 32 leaves, where each leaf is the hash actually of a one-time public key. And then it has 3 interfaces, as a standard signature scheme has 3 functions. It has a keygen function that outputs a public key and a secret key. It has a sign function, and it has a verify function. Okay, and the first kind of unusual thing is that we take as input for sign and verify these epochs. And epoch is a bit of a misuse here, so think more like slot. So an epoch is just the pointing to the leaf. Okay, and I think the most important takeaway whenever you use this library in terms of security, and I can't stress this too much, is this is sort of what you need to ensure if you want to get security. You never call this function twice with the same secret key epoch pair. Okay, this is sort of the one restriction that you don't have in a standard signature scheme, but in this scheme you have it. This is very important. Okay, now let's look at KeyGen a bit more closely. So it takes as input these 2 parameters. First it didn't, but now it does. What do these parameters mean? So it could be that you are a client and you say, okay, I don't want to have really a lifetime of 2 to the 32 slots. Maybe that's too long for me and it takes too long to generate the key. Maybe I just want to be active for this period in time. Okay, so what you would specify when you call keygen, you specify a pointer to this first epoch. Let me just call it epoch, but think slots. And then you specify for how long do I want to be active. And then what the keygen function internally does, it generates this sort of sparse Merkle tree where actually only this part is generated, and then the rest is filled up with random nodes so that you can have copaths. Okay, so how long does this take? So KeyGen is really the slowest algorithm in this whole thing. It takes linear, and all of this is times the time that it takes to evaluate a hash function, linear in the number of active epochs plus some log L. log L because you need to complete this here. So if you go for like 2 to the 32, you really want to have the full lifetime. That's really, really slow. And that would take hours or even days, I think days probably. But maybe if you know, my validator lives for 500 years, then maybe generating a key for 2 days is probably okay.
How is that? How is for KeyGen? Is it faster? Because I still need to compute those authentication terminals.
What?
If I run a KeyGen for this subtree,
yes.
You say?
Yes.
And then I still need to produce the public key that will.
This one?
Yes.
Yeah. So you generate this tree.
Yeah.
On every layer, you need to pad it sometimes, but you add at most 2 nodes that are sort of artificial nodes, and then you compute the next layer and so on.
Those are not fair,
right?
Fair keys.
This is not filled. This is sort of a sparse Merkle tree, so that this one is actually filled, and these ones you extend them using your PRF seed. And then to make sure that you can, for all of those, compute the Merkle path, you have some random nodes that sort of fill it up. But it's just log L many.
Yeah, makes sense.
Dimitri?
Yeah, maybe a little comment on this never call twice. Maybe that sounds a little bit scary, particularly when testing. Can we say rather never publish twice? If it makes sense for...
I mean, never publish twice, what does that mean? If let's say I call it twice, and then I take the second one and somehow use it to compute something else. If I then leak that something else, I can make no guarantee about security. So what the security model that we have says is never call this twice.
Well, we have already called it technically to generate the key, right? So you have already used the secret key to generate all the chains. So technically you cannot say that you...
never call this function twice. Sure, you can call this function, but like...
What is the repercussion of calling it twice?
You would leak parts of your secret key.
You can call it twice under the same message, but I think easier state.
You cannot, because there's a randomness going on.
But is it PRF randomness?
You mean the row? That's the randomness.
What can it be deterministic, the randomness?
You take a secret seed, you take some iterator, you take the message, and this will be not a pure randomness, but a PRF randomness then.
This could work, yeah.
So
but still, I mean, never publish twice is just not a well-specified thing, because what does it mean to publish the result of that? If I now take it, I remove a bit, and I publish it, is that publishing or not?
Yes, well, we're not purists here, but...
Oh, I am.
This remembers me a bit of ECDSA story, right? That like, when you never
reuse the nonce, right?
Yeah, and then like we had like Sony that did that, and the PlayStation. So if there's anything we can avoid situation of leaking the secret key, I will. If there's anything that can be done.
Yeah, I mean, for me, this is the thing that needs to be clearly documented, and I think right now it is.
Maybe if there is any chance to make the library stateful, just to encapsulate this requirement internally.
Oh, sure. Okay, we can make the secret key. Then you need to make this function so that this function can write to the secret key, right?
Yes.
This is maybe coming to the
I mean,
future API. This may be a problem in terms of concurrency.
So some epoch whenever you sign it.
Yeah, then the secret key would store I have signed that already, and then when you call it a second time, it just abort. That is a good way, but then this function needs to have write access to the secret key, which is maybe a problem for the future API that has multiple functions taking the secret key.
I'm not sure about secret key. You just have to mark epoch as used.
Where do you mark it?
Yeah, I mean,
somewhere.
Yeah, in the client, right?
Yes.
So this current API, which I'm not saying we should keep this, I'm just saying this is the current API. This current API says the client needs to keep track of what it has signed and what it has not signed.
So right now, each client has their own anti-slashing mechanism. But I'm wondering if we could kind of simplify things for clients and just do anti-slashing directly in the signature library. I'm also thinking, could we have like defense in depth, where we have like anti-slashing in the library and anti-slashing in the client?
Or maybe adding a new parameter, nonce, on the signing, you add another parameter.
What would that help if you have nonce?
Or randomness. So
Why would that help?
hopefully people don't pass the randomness twice, the same randomness twice.
But if they use the same epoch, even with a different message, that's still a security
That's
violation.
the core problem, to use the same epoch with the different message. If we're just signing the same message, I think we can make it produce the same data. But if it will produce a new signature under the same epoch, that's the problem.
Yes.
So if you sign with the same secret key, same epoch, same message.
Currently, in the current implementation, that's a problem because signing is probabilistic. If we now
Well,
make
I didn't finish my question yet. The question is, would you get the same signature both times?
Currently not.
So this is not a pure function. There's some additional state.
Oh, it's an algorithm.
The output
Randomized
sign
algorithm.
depends on.
No, there's no state in this function. It's just a randomized algorithm.
So if there's no other state that it depends on besides those three parameters, then it must
And
follow.
a randomness generator.
Okay, so what is the randomness generator?
That is passed as input to this thing currently.
Okay, that's an
Currently, I don't
additional
care.
parameter.
Yeah, I
right,
didn't put
that's
it on
not
the
written
slides.
there.
Yeah, that's what I meant. I mean, you can, if you pass now you're using the randomness inside, right? So you produce different value. But if you're passing the random as an input.
Yeah, but then you don't solve that problem. If someone
But you give
takes
the
a
same-
different message and calls this, then it's still a security violation. Anyway, I think we should not spend too much time on this. I think there's a more pressing problem. I think I agree with Justin that we should try to ensure this as good as we can, ideally in both the library and the clients. And yeah, we can do that. Okay, but coming back to KeyGen. Okay, so KeyGen takes that much time. There's no way to improve this. So with this design, with this scheme, we have to pay the price of a large KeyGen time. Okay, now what about the secret key? Currently, the secret key is the seed and the entire tree. Why did we put the entire tree in the secret key? Because we want fast signing. Okay, what is the size of this tree? It's this. So it's linear in the number of active epochs. Then you have some 2 times log L, and that many hashes is what you have. And the hash is 31 byte. So it's 38 field elements, and each field element is 31 bit. Okay, so this can actually go to like very, very high number of gigabytes. So if you have the full tree, that's 2 to the 32 leaves. That means the tree has about 2 to the 33 nodes. Then this term is 0, like there's no additional thing on top. And that times, so 2 to the 32, 33, and that times about 32. So that's 2 to the 38, many bytes. And that's, I think, something like, no, it's even 256 gigabytes. So it's even more. Okay, if you populate the full thing. And with the current implementation, we even would have to have that in RAM. So this is not doable currently. Okay, so this is the current API. And I think the main challenge, if we now want to change this API, is we want to give the client flexibility. The clients should be able to decide how much memory they want to give to the signature library, or at least to some extent. They should be able to decide when to store something on disk and read it later, or when to sort of regenerate parts of the tree. But at the same time, we want that most of the cryptography is really encapsulated in that library, and clients should ideally use this library as a black box and don't look into the specifics of how this signature scheme works. Okay, so here's a proposal, and I already can tell you I'm not even 100% happy with that proposal. It's like one way to do it, I'm happy if there are any other suggestions that are better, or if we can play around with it. This is sort of a starting point. Okay, so let's start with KeyGen. KeyGen would take the same inputs, but now it would output three things: the public key, the secret key, and some auxiliary value that you have initially. Think of this as being the full tree, or the partial tree, or empty. We could even maybe have like a parameter here that says, do you want to keep the full tree in this auxiliary value, or do you want to have some partial tree, or should it be empty? And each such auxiliary value, which will show up a bunch of times in other functions, should have some way to tell us in which interval it is valid. So for which interval of the tree we can use it to sign. Okay, and then we can sort of play around with that. Let me come back to that in a second. And then when we sign, we not only pass the secret key, which is now just the PRF seed, we also pass any auxiliary value that we currently have. And this is still fast, assuming that the epoch is in that interval specified by that auxiliary value. So think of, for simplicity, think of this auxiliary value as being all co-paths that you would need when you want to sign in this interval. Okay, and then you could either write it to disk or throw it away and recompute it later, or just store it in RAM, whatever you want, depending on the size. And then there, of course, need to be some ways to play around with these co-paths. So for example, if you decide to throw it away after key generation, how do you get it back? Because you need it to sign. Well, we could have a function that takes any auxiliary value, which could be empty, and sort of extends its interval. So it would internally compute more Merkle paths, or like populate the tree more. And maybe we don't even need this in full generality. Maybe this function next aux is sufficient, where we just say, okay, I want to be prepared for the next epoch. And then I call this in some thread way before I have to sign for that slot. And then I'm prepared, and then in that slot I can sign very fast. And if we do that, then we can actually implement nice tree traversal algorithms for Merkle trees that sort of have some certain caching behavior, and that have a good trade-off between memory and time. But in the worst case, this time for playing around with these parts of the tree with the auxiliary value can take as long as KeyGen. I think Mike corrected me, it's like half as long as KeyGen in the worst case. But
maybe it's maybe not.
If you go from the left subtree to the right subtree, like this sort of takes long. And then clients would need to decide when to call this, whether to store this in memory and read it, or whether to throw it away and so on. Yeah, so this is one way to do it. Verify would be the same, of course. So
I would add here an important thing is if we take in the signing this if we take in the signing this extra input.
Yes.
So essentially, this extra input somehow contains intermediate nodes of Merkle tree. You can do it different ways, and the idea is that the signing then, when it will take this given intermediate node, has to check whether the signature will be validated afterwards. It's not
right.
only that it's interval. The problem is if your extra input was corrupted due to misuse of the computer or adversarially or whatever, the problem, what will happen if you produce an invalid signature? Because you will get punished probably somehow in the protocol. And so the requirement here will be, okay, I take those values, I put them, but I will do the same process as validator. This is still faster, but I need to check that this extra auxiliary input was not.
Yeah, I mean, I think it's in general a good idea that the signing algorithm before it outputs the signature checks that it's valid.
Yeah.
That is again some sort of hardening mechanism. Yeah.
Yeah, so if we keygen, if we call the keygen and get auxiliary output, is activation output, is the parameters are related to the A and B, the get interval?
Yeah, so that good question. I think I did not decide that in that way of presenting it because I say either full tree or partial tree or empty. Let's say we go for full tree, then the interval AB would be A equals activation epoch, B equals activation epoch plus number active epochs -1 or something. But we could even decide that we have either multiple keygen functions where one outputs the full tree, one outputs the partial tree, or we would have just a parameter given to that keygen function that says, okay, I'm a client, I want to generate a key, I want to keep track of the full tree. And full tree here means this sparse tree, like not the 2 to the 32. Or I say I'm a client, I want to keep track of nothing because I want to be very efficient, I want to not have that much memory, and then keygen could just not output anything. Yeah, so this is, you can always get back these auxiliary values by calling these functions. I'm not even sure if it's 10docs is the best way to call it, like, yeah. So we would have some functions that take the secret key and give us a new part of the tree that we want.
I wonder if clients do need this sort of kind of extra flexibility. Wouldn't it be okay if we just provide a single optimization scenario where we like cut the tree in half, so that eventually what you have store and use is just the square root of the total tree size, and
yeah,
that's kind of the only option that you guys have. Because maybe if we look at this closer, maybe it should be okay for everyone, so that they don't even bother with selecting parameters and so on.
right.
Because, for example, here we probably, when we kind of allow given arbitrary parameters, we'll have to say, oh well, if this things is within subtree, then it's fast. If it's kind of goes to the next subtree, it's super slow. And clients start kind of thinking this extra information about the details of the tree. Maybe kind of just one variant.
Yeah, I agree, and I think that's also what I thought first. I think there's maybe one caveat, that is, if you have a client that generates only a very sparse, a very small part of the tree, then why would that client want to have this sort of split it up? I mean, if that client could just keep the entire tree, right?
If it's small, then and these two use this trick, then kind of regenerating this subtrees every square root of the size is not a big deal for them anymore.
Right, but if it's small, then why would they even need to regenerate it? Why, they could just use the current version.
Yeah, they could, but even if they regenerate it, wouldn't harm them terribly.
Right. I mean, there's also the question: do you regenerate it, or do you store it on disk and load it?
No, you store the top and you generate the bottoms.
Right, but you could also, instead of generating the bottoms, put them into, I don't know, 2 to the 6, like some number of files, one file for each thing, and then
I agree. There can be tons of different optimizations. I just wonder maybe just one single variant is okay, so they don't.
Right. Yeah, I agree. I would really, from the perspective of developing this library, I would really love the most simple API where I don't need to have all these functions and think about what could happen now.
A question, like, which one is like the public that will go on chain or whatever?
The root, the Merkle root. So the public key is this one. I mean, it's a slightly lying here. It's the Merkle root plus a public parameter, which is 5 field elements. So the public key is 8 field elements plus 5 field elements, 13 field elements that go on chain. It should be around 60 bytes or something. Yeah.
So if we use the new proposed API, do secret key contains the tree,
No.
or so the initial aux does the same thing as the tree in the secret key, right?
Right. Think of this pair as being what currently is the secret key. Yeah. And now it's harder to give that, like coming back to this never call the thing twice. Now it's even harder because now we have more functions that take the secret key. And now these functions, if they are implemented correctly, you can call them as often as you want. They should not leak anything about the secret key. Whereas this function would still have the same restrictions as before. Yeah.
I want to suggest a slightly different way of doing this that I think might help. I'm wondering if it's been considered. So it seems to me like the situation with these keys is that you need to like the more time you want to spend offline between using your key and refreshing your key, the bigger the key has to be. And so, for example, with the current idea, you could be offline for 2 to the 32 slots before you have to come online to refresh your key. It seems to me like maybe you could replace this idea of 1 leaf per slot with 1 leaf per instance of signing. So for validator nodes, which sign, I assume, once per slot, it wouldn't make a difference in terms of, how frequently you need to refresh the key related to the signing. But validator nodes are like online most of the time, as far as I understand. And so they could plausibly have a smaller key than 2 to the 32 leaves because they're online and they can presumably refresh their key at some frequency. And then for wallets, some people are going to want to have their wallets offline for a long time, but then they're not going to be signing in every slot. And so.
What do you mean wallets? I mean, this scheme is just for consensus layer for validators.
Okay. So
for like execution layer, we would not use a stateful scheme or like
so the transactions are going to be signed with what type of signature?
I don't know.
Okay, I was assuming they would be signed with this kind as well, but I can then restrict my comment to just the validator nodes.
Right, and maybe to like, where is it? Okay. Yeah, maybe this. So the reason why we allow that sort of the party that wants to generate a key for 2 to the 10 slots that we allow that this interval starts here in the middle of the tree and not. I mean, we could have said, okay, if I want 2 to the 10 trees, then I always generate this leftmost part. But then the problem is that if you have multiple validators that sign and you want to aggregate those, then the paths that they take in the tree are different. And if we do it like this, then they always, if you are in slot I, then the party who is aggregating knows, okay, slot I means this is the path that I follow. And so at least from what I understand, proving this during aggregation is much more, it's much easier if they have sort of the same, if they take the same path in the same slot.
I think the bigger reason has to do with slashing, right? So you might want to slash like very old messages, and here you need to have in the state all of the pub keys. So you want immutable pub keys. So is the idea that you refresh the pub key? Maybe I misunderstood the idea.
No, I was just saying why do we have an activation epoch and why not activation epoch always 0?
Oh yeah, that's just for simplicity.
Yeah.
I also think for now the secret key contains just the seed and maybe extra information. But with this keygen, the secret key should also contain the range.
It does. Yeah.
Okay. Because if technically
I can still currently
produce...
this sign first checks if epoch is in the range.
Okay. Yes. Okay.
Yeah, I simplified a bunch of things on the slides, but yeah.
One thing that could be helpful is knowing the performance of keygen, and not just the performance today, but also the predicted performance. My understanding is that we're not using CMD right now.
That is correct.
So we could get like a free 8x basically improvement.
Yes.
And if I remember correctly, we were doing like 1 day of keygen per second or per minute.
I don't
per second, I think.
That metric. I just know like it was like 8 years and it took a few hours. But I mean, that's hard to come up with a number now.
Right, so 8 years times 365, yeah, so yeah, a few thousand. So I think it was like roughly 1 day per second. And now per second, if we multiply it by 8x, that's like 8 days per second. So I guess I'm wondering if we go with the super simple approach of Dmitri's approach.
Yeah, which I like. I mean, I want this to be simple. I guess the question with the simple approach is more to the client devs. Would that be something that you could use, or would that be not flexible enough? I guess that. So do you recall what Dimitri's approach was? Maybe we can write it down on the board or something.
I can write this.
Can I ask a question while we're getting ready for that? Why do we need these keys to last so long? What is the trade-off if we just make them smaller and refresh them more frequently?
So, as I understand currently the only way to refresh a key would be to exit as your validator and then join as a new validator. And I'm not sure if people would want to do that every year.
Oh. Sometimes like the queue is really long, so it can be like days. Maybe now not, but there's been days that like the queue to like go on chain and do any deposit or consolidate might take long.
Okay.
The execute is 40 days right now.
Yeah.
Is there any way we could have a mechanism for validators to just renew their membership?
It's on chain, so it's like.
This goes back to the slashing comment. You want to be able to slash arbitrarily past attestations. And if you've refreshed the root, then you can't slash anymore because the old attestation is relative to a root that is no longer stored in state.
Okay, so basically in this simple optimizations, don't worry. Suppose we have a tree of size of the L, and basically we chop the tree into 2 layers, basically, and we store the top L/2 layers, which in our case is most of the 16, and the part we are the subtree of height 16, which is again to the L/2 size, we regenerate. And this to store is again to the 16. So basically, when we are in the subtree, we keep it, and when we reach this step, we just regenerate next ones. But since it's 2 to the 16, it's not really much, and the total amount of memory you need is
like 2 megabytes, I think, for the top tree.
Probably yes.
2 to the 16 times
13, 2 to the 4. 2 to the 13 is 2 to the 4.
Well, one hash is
30.
32 5.
Yeah.
So that's 2 to the 5. So that's 2 to the 21 5. That's like 2 megabytes. 2 megabytes, right? That's it. That's okay to have that in RAW.
That's okay.
One.
Just one. I mean, if you are one validator, one is right. And then the question is, do you want to regenerate this, or do you want to store it and load it from disk? And I think we could even support both options. Maybe we can give you the freedom to choose.
So that would be the so 2 to 16 slots would be the equivalent of 3 days, which would take less than 1 second with the SIMD optimization. So
right. So you have an interval of 3 days, and during that time, whenever you want, you can generate for the next interval of 3 days.
Yeah, I mean, there's also the super simple logic is like you literally reach the very end slot of that 3 days, and then if it takes 1 second to generate the next 3 days. So you don't even need to pre-generate necessarily because it's so fast.
Right, but I guess it would be good to give clients the choice when they want to regenerate.
They have the choice.
Okay, so maybe if people think this is okay, maybe we can like write down the API for this method, and then we can implement it after the. Emil?
Yeah, so I have more.
Yeah, just a small question. Like once a validator decided to update their key, do they need to sign it with this schema? I mean, if it's one-time signature, then
what do you
instead
mean with update the key?
I mean, well,
Public key?
yeah.
No, I'm
How do they do
updating the public key. I think the only way is to just leave as a validator, and then exit. But
how do I signal that I want to leave? I need to sign some message or
same
something.
way you do it right now.
But do I need to sign it with this key? Because I can't, because it's one-time signature per slot. Or I do it with another kind of key.
I mean, we could reserve the last slot for the exit message or something.
Yeah, but I don't want to exit on the last slot. I want to be able to do this in the middle. For example, I suspect that my keys are compromised and I want to update.
Okay, but then just for that slot where you want to exit, sign a message that says I want to exit, but don't sign anything else.
Yes.
Is that okay?
That's okay. Yeah, I'm just saying.
I mean, you can choose what you want to sign, right?
Yeah.
The signature library doesn't tell you what the.
Yeah, as long as it is okay for me not to sign attestation for this slot, but instead sign the message that I want to leave. If it's okay for everyone, that if we don't see any problem with that, then yeah.
I see. Before you got the slots for blocks that you're signing, now your leave message, you need to control yourself that you're not reusing the slot.
Right, but I mean, why not just? This is just about what do we sign? I mean, we could just say, okay, if in one slot I want to sign the block and I want to leave, then we just define a special message format that has these two components, and then you sign the hash.
Yeah, but this is just another careful, just not to reuse the.
Right. But I think this should not be part of the signature library logic. This should be part of the client logic.
Yeah.
Yeah. So in this setup, so we only have to sign once with the same epoch. So in practical, there's quite a multiple domains to sign. For example, block proposer should sign to block, a tester should sign to attestation. So is there any advice or recommendation for the multiple domains?
Yeah, I think that's a good question. I don't have a perfect answer for that, but there are multiple options. One option is to have two keys, probably not the thing that we want to do, because it like doubles the size of all keys that we need to store. The other option is to pack these two things that you want to sign in one message. That of course only works if you sign at the same time and not in two different times. Probably that works for the proposer, I'm not sure.
It does.
I think that's the simplest one. Then there's the other thing where we sort of virtually cut the lifetime in half, and we say like every even odd is for being every even leave is for being a proposer, every odd one. But then we really cut the lifetime in half, which we probably don't want.
Inefficient that case.
Yeah, so I think without thinking too much about it, I think the packing two or multiple messages into one message that you then sign would be the.
But does block proposer sign foremost of the attestation in this current beacon chain setup? So you mean that packing means this should publish at the same time, right?
There's only one message, which is the block message that you're signing, and within the block message, there's an attestation message.
All right.
Which is on-site.
Understand.
I guess I have a very basic question maybe for Justin. The question is, do we want to get rid of the notion of withdrawal keys and validator signing keys?
Yes. Please.
So we would, I guess, only have a withdrawal address, which is an if1 address. So when you withdraw, it's just basically a pointer to where you want the funds to go. So that's the question.
I guess this ties into the exit message debate we just had. So
yeah,
right now we can trigger exits from the execution layer. And so, yeah, so there.
Yes, that would be actually a very clean solution where you just trigger your exit from the execution layer, and then we don't have to worry about signing a withdrawal message from the consensus layer.
This is not possible, right?
This is now possible.
It's now possible, yeah.
So, yeah, probably that's the thing.
That's the cleanest, yeah. And it keeps the consensus layer super minimal as well.
Right. I think someone said that if we'll. I can't remember who said that if we'll design now the beacon chain will not add the withdrawal key. So I don't know if it was saying in some backlog sometimes they were right.
Yeah, makes sense.
But okay, just to clarify, could you trigger a withdrawal from the consensus layer?
Or
like with this, because then you would obviously have to use your post-quantum key here as part of the scheme.
We could do it either way. So one thing that Benedict said is we could say, okay, if the epoch is 2 to the 32, then that has a special meaning. It means that it's the withdrawal message that you're signing.
There's one problem with that approach is that if you generate a tree that looks like this, but now you also need to generate the 2 to the 32 slot.
Right.
Now your tree will not be of that form, so you have a bunch of intermediate nodes, and then I'm not even sure if that, in the worst case, could be, again, a very long key generation time.
Right.
I'm not entirely sure, but like I could imagine scenarios where this would lead to a long key generation time.
Remind me again. How long are we expecting those two? How long are we expecting those 2 to the 32 keys to last?
Over 100 years. 500
years?
Something like that.
Yeah.
Because that's like what, 4 million signatures? 4 billion signatures. We do this? Okay.
Yeah, 4-second slots you can commute.
544 years.
Okay.
I think if you just want 10 years, you can do something like 2 to the 28 or something, but
yeah.
I think the nice thing about this, so first I was skeptical about this, like why do we need that long key lifetime? Why just make it 2 to the 28? But with this, now every client can, or every validator can decide what they want, and 2 to the 32 is also kind of nice. 32 is the power of 2, is like really, we give maximum flexibility, and it's not a weird number like 2 to the 28. Why did we pick that? And then if we at some point go from 4-second slots to even less seconds, then we are prepared. Thomas?
Is there a way to enforce at the API level the fact that this is impossible to?
Yeah, we were discussing that before. I think there are ways. I'm not happy with either of them. I mean, you could store in the secret key a bit vector that says, this is what I've already signed. Then the problem is that this function needs write access to the secret key, which is probably okay, but harder to deal with if you do things concurrently in the client. Like I want to call 2 functions that use the secret key, for example, one that regenerates the next part of the tree at the same time, and they both need write access. You could have a separate sort of mask that goes in there, but then who controls that this mask is correct? That's again logic of the client.
So you don't need a mask. Much simpler approach is just to store the last signed epoch, the last used epoch, and then just enforce that the epoch number must increase.
Right, but I think it would have the same problems.
It's just simpler than the masking.
Sure, okay, simpler implementation, but same problems.
Correct.
That you have this function needs write access to the secret key, which makes it actually stateful. This API is not stateful.
Can we just say on this here? I mean,
yeah. This slide?
No, this sign things. I mean, as far as I understood, I'm not really familiar with that. Like, the problem is like that if you sign twice, you get two different signatures, right?
For the same one-time
Exactly.
secret key, public key pair.
Exactly. So can you just having kind of instead some deterministic, as you do like in ECDSA, we do like, for example, for
yeah, but if you'd use this, okay, so this, the problem, there are two problems. First, you sign twice with the same message. This one you can solve, like you said, what also Mike said before. You make currently this thing is randomized. We make it pseudo-random. So if you sign, and this pseudo-random function can be even non-snark friendly, right? We don't care. It's not in the verifier. Also an easy change. We should do that for sure. So that if you input twice the same message, you are fine. But if you now sign twice with different messages, of course, this will produce different pseudo-random coins for this algorithm. And so you're screwed, right? Because signing two messages with this one-time signature that is sitting in the leaf can lead to a break. I can try to explain if you want.
Yeah, please.
Okay, so remember that the scheme has this form where we have these hash chains. Let's try to make it simple. I use 4 chains of length 3. Okay, so this lowest layer is our one-time secret key for this epoch. This is our one-time public key. Now let's say I call this and my message, there's an encoding step happening, but let's now identify the encoding of the message. Let's say my first message is 0011. So it's this would be my signature. Okay, now I sign a second message, which is 1100. Oh, you can see. Okay, do you see the chains at least? Or should I redraw them?
it's okay. Change sounds good.
Thank you. Okay, so that's the chains, right? And the message corresponds to a vector of positions in these chains via the encoding. But like, let's say we ignore the encoding for now. So my first message is 0011. That means I publish as part of my signature this thing, this thing, this thing, and this thing. Okay? So now the adversary says, okay, please sign a second message for me. The second message is 1100. You cannot compute the signature for that message from that message, because in this chain you would have to go back. That's why it's secure for one message. But if I, as a signer, reveal the signature for that message, then I reveal this guy, this guy, this guy, and this guy. And now you see I've revealed my entire one-time secret key. So now the adversary can sign everything he wants, because he has my one-time secret key for that epoch.
So suppose that happened by mistake, but I noticed that it happened to me before the rest of the world. What should I do? Like, is there like a panic function that immediately?
I don't know. I would just exit from the validator set, but I'm not sure if that would happen in time before someone can.
But for now, we don't have anything, like we just have a warning in the comment of the function, but for now, we don't have any sort of prevention for this.
Right, and I think the only way to prevent this, like strictly prevent this in the signature library, is to make it stateful. And by stateful, this would mean that sign writes or updates the secret key, which I don't know if you want that.
So you can have sign be stateful, but kind of in a different thread, so it doesn't block you. If you sign different things all at once, kind of, you're not blocking.
No, let's say you have two functions, right? One allows you to regenerate the next part of the tree that needs your secret key. The other function updates the last signed epoch in the secret key. So both of these functions now have write access to the secret key. If I call them concurrently, then wouldn't that cause problems?
Yeah.
If I do it like,
I'm saying you can.
It would be
you
possible.
can call them concurrently, Okay, you allow them to sign quickly, and then you have a different thread that's kind of remembers what's signing, and then in a synchronous way checks if something was signed twice.
Right.
And then just alerts like, oh, panic alert, you did something bad.
The question is, do we want that in the signature library or in the client? For me, I thought this should be the client.
Yeah, maybe.
Well, you can use a mutex, right, to prevent concurrent access to the state.
You can,
but
you
then
can.
It's slower.
I guess it would be fine because signing doesn't take that long, right? Signing is extremely fast. So.
But you can also split your secret key in kind of two parts, because you will only write in the part that is technically our epoch control comes from the environment. And so if something happens to that part is not that crucial, this is our kind of secure mechanism double check of like that we are not calling this twice. And then you have your secret seed that you can use in keygens and stuff. And then you have your state also kind of part of the secret key, but it's just like
so
logically split.
This would mean you have two inputs here.
Two secret keys.
Secret key and when did I sign last time?
Yeah.
But what's the point of this? I mean, anyone can input anything, right?
Yeah, but you can, while your keygen is not conflicting with that part, you can still have it as a single.
I'm just saying that this doesn't make it.
You can still have it as a single input as like a secret key.
I'm saying this doesn't make it more secure. Okay.
Maybe you progressively delete each part of the secret key that you use.
You can always regenerate it, right? If you are.
Could still serve as a guardrail.
Once you, let's say if you sign twice, someone got hold of it, is it only just the future signatures that can be signed, or can you also
just for this slot actually?
Over.
If you sign twice for slot I,
yeah,
then this doesn't affect your security in slot I+1. It affects your security in slot I.
Okay.
One question. In the code, usually there is a lot of recovery mechanisms that if some thread fails or if something fails, like things get redone, like you try to keep running. So there is a possibility that something crashes, it puts again and signs again. That's kind of the normal flow. So,
but wouldn't
I think
currently the clients should have anti-slashing measures, right? They should already somehow make sure that they don't sign two different messages for the same slot, right?
Yeah.
Why isn't that enough? That was sort of the whole motivation why we said synchronize or like stateful schemes is fine for this.
Okay, I see the argument. It makes sense.
Yeah, no, I mean I see what you're trying to achieve. I'm not sure if there's anything that already achieves it, because if you input just a second thing, that thing can come from the client. If the client is buggy, that thing is buggy, then this check and this signing doesn't really help.
The only thing I'm thinking is, well, sometimes client do get slashed. Well, it's better to be slashed than lose your private key. Right? Because your line of argument is, okay, you will get slashed if you sign twice. But maybe the client says like, okay, it's fine maybe to get slashed 1 in 10,000 times.
Right, but it would not. It would lose the secret key for this, the one-time secret key for this slot, but not for the next one. Which we didn't prove, but it's pretty obvious.
No, it is true. But the problem is, if I got my secret key for this slot leaked, can I then be punished by some adversary that will continue signing bullshit messages and I will get punished for this?
Yeah, I think so.
Yeah, so this can be an issue, because if I lose the slot for specific slot, someone can just continue generating signatures and I will get punished.
No, you get punished once.
Punished once.
Yeah.
Okay.
And then you exit.
Okay.
Can you like sign like maybe 10 different blocks for the same slot, and then if you're a slasher as well, you take the same message to announce that you found a double sign?
Yeah, but there's only at most one slashing per validator.
Okay, that's good.
Okay, I think we maybe one or two comments, then we have to wrap up.
Yeah, so it's not exactly about the signature themselves, but more like the usability compared to what I do for my own validator. So when I created my signing keys, right, I still have my withdrawal keys that are on a cold wallet somewhere in a bank safe, and I have the signing key that is on my validator. What I would want potentially using this API, so sorry, not this API, but the next one, the one with the auxiliaries, is to have the master key in cold storage, only generate a given interval, but leave it in the cold, leave everything to generate the next interval in my cold storage, and just generate 10 years worth of keys, right? And 10 years later, I still have to do a new session. And my question is purely in terms of usability. What if there's a problem because I generate a new interval?
Actually, what you said doesn't work with the current scheme.
Sorry?
What you said doesn't work with the current scheme. Because sign still needs the secret key, which is the one long-term PRF seed. So we would need something like a constrained PRF or something like a more fancy cryptographic object to sort of have sub-parts of that. Or you do it in a trivial way and your secret key is now one PRF seed for each chunk. That is also possible.
Okay. Right. Okay. I think I got it. But my question is more a usability thing. What if I generate, an interval once and then accidentally I regenerate for the same interval? It's not gonna be the same keys, right? Because there's a randomness aspect to this.
It will be the same.
It will be the same.
So these two functions should be deterministic.
Oh, okay.
Yeah.
So where is the randomness then?
In sign.
Ah, it's in sign.
And in KeyGen, of course.
Okay, then that works.
And in sign, we can de-randomize it, which we should.
Okay, thanks.
Okay, I think
maybe one last question. In terms of the key size, with the current parameters that you suggest, we are at 3 kilobytes for the signature size, I think.
Yes.
Is there any other future work on that to reduce that, or is that like that's the number?
Okay, so
we should work with that.
Probably the disappointing answer is that if anything, it will go up because for snark friendliness, we will have sort of we think about removing some of the size optimizations that we did, for example, using tweakable hash functions, changing it back to just without tweaks because that would be easier to prove. So at that point, it may go up slightly, but
4 kilobytes. I don't know.
Hopefully it doesn't go up, but I hope we can find a way without increasing signature size. Okay, thanks a lot for the session. This was very